Hello friends, we are back with our new video. In this video, I will discuss how to draw a function in R or R Studio using ggplot2 that you can use for your official presentation or in your publication. Please visit our website statswithR.com for more details, and if you have any queries, shoot us an email at learnstatisticswithr@gmail.com. The overall process involves several steps and I will discuss stepwise. So let's begin. There are many types of functions. Here we focus on three types of real valued functions that we come across in the statistics context. First, we consider a continuous function. As an example, we consider the normal density function. Once you learn how to draw it, you will be able to draw the density function, the cumulative distribution function, quantile function, survival function, etc. of any continuous random variable. Second, we consider discrete function. As an example, we consider the binomial probability mass function or PMF. Once you learn how to draw it, you will be able to draw the PMF, cumulative distribution function, quantile function, survival function, etc. of any discrete random variable. Third, we consider a discontinuous function, which is slightly more rare than the previous two. As an example, we consider the density function of a random variable that follows a standard half normal distribution on the negative real line including 0 and a standard exponential distribution on the positive real line. Note that this density function has a discontinuity at 0. Now let's get into drawing them one by one. The simplest is the continuous function, and so we start with them and then discuss the small changes to get the other two. Here I consider one way to draw these curves that I feel the simplest, but of course there are other ways to draw functions in R using ggplot2. Okay, here we want to draw the density of a normal distribution with mean 5 and standard deviation 2. First, note that the density function is defined over the whole real line, but of course we cannot plot it over the full support. So we need to draw a curve over a finite interval, and thus we need to evaluate the function at a fine grid over this interval. Let's see the code step by step. First, we want to select that interval and then want to create the fine grid. We should choose an interval where the characteristics of the function are more interesting. For example, a normal density has 99.87% area under the curve just between the 3 sigma limits, that is the interval with the left end equals to mean minus 3 times the standard deviation and the right end equals mean plus 3 times standard deviation. So we create a fine grid called grid.x within that interval and consider 10,000 grid cells. This makes the grid sufficiently fine. Next, we evaluate the normal density with mean 5 and standard deviation 2 over this fine grid and store the values into a vector norm.density. Now I just need the two vectors grid.x and norm.density. Forget about everything else. Before we move to create the ggplots, first we need the package ggplot2. So we need to install it and call it into R or R Studio. For this, we use the commands install.packages and library. Now we are ready to create the ggplot. In the console window, type ggplot a blank bracket plus geom_line within aesthetics x equals to grid.x and y equals to norm.density. Now press enter. Okay, you get your first normal density curve. The curve looks quite narrow and you might want to increase the line width. To do that, within geom_line outside aesthetics, we set size equals to 1.5. The default size is 0.5. Thus setting the size equals to 1.5 increases the line width. Now press enter. Okay, you get your second normal density curve. We can see that the axis titles are just the names of the vectors. For making this figure a presentation quality one, let's make some changes. First, let's rename the axis titles by value and density respectively, as this makes the plot clearer to your audience. To do that, add the line xlab value within quotes plus ylab density within quotes. Now press enter. Okay, you get your third normal density curve. You can see that the axis titles have changed. Next, you might be interested to add a title, say normal density at the top center. To do that, add two lines. First is the GG title normal density within quotes. This adds the title. The default position of the title is left aligned. To move the title to the center, add the line theme plot.title equals to element underscore text h just equals to 0.5. Now press enter. Okay, you get your fourth normal density curve. You can see that the figure title is created now and also it is at the top center. Next, note that the axis titles and the plot title are quite small. When you use this figure in your paper, it may be just a 2" by 2" image, and then these titles will no more be readable. To enlarge them, add the line theme axis.text equals to element text size equals to 20. This increases the font of the axis. Axis.title equals to element text size equals to 20. This increases the font of the axis titles, and plot.title equals to element text size equals to 20. This increases the font of the plot title. If you don't need one or two of them, you can remove those lines. The larger the size you want, you need to fix a larger number. So choose a number accordingly. Now press enter. Okay, you get your final normal density curve. You might consider this density curve for your presentation or in your publication. Next, we move to the discrete and discontinuous functions. But we just discussed the small changes you need to do along with the code you have until now. We will not discuss it again from the scratch. Now we move to the discrete functions, and as an example we consider the probability mass function of the binomial distribution with size 10 and success probability 0.6. We follow the similar strategy as earlier and evaluate the PMF over the support. Note that the support of the binomial distribution is the set of integers 0, 1, 2 up to 10. We create a vector of these integers and store them in grid.x. And then we create the vector bin.pmf that contains the PMF values evaluated over the grid.x. Now we just need these two vectors and forget about everything else. First, we just run the same code we have so far with some little changes. The inputs within the aesthetics of the geom line are replaced by the two new vectors, and further we change the names of the axis title of the y-axis from density to PMF and the plot title from normal density to binomial PMF. Now press enter. Okay, you get your first binomial PMF plot. Note that this figure is less meaningful as this has a continuous x-axis, but we should have only some discrete integers. Thus, we need to consider a bar chart instead of a continuous curve. We have a separate video on how to create a nice bar chart in R using ggplot2. For the time being, here we just make some small changes to the codes we have so far and proceed. Let's see the changes in the code. Because we want a bar chart instead of a curve, we replace geom line by geom bar. Next, note that within aesthetics of geom bar, instead of setting x equals to grid.x, we set x equals to as.factor within brackets grid.x. This makes sure that the x-axis of the figure would just be some integers and there is no meaning of the PMF at say 2.5. Although theoretically it is just 0. Another thing is adding mapping equals to identity within quotes inside geom bar but outside aesthetics. This tells the function geom bar that we have only one value of bin.pmf corresponding to each value in grid.x. Now press enter. Okay, you get your final binomial PMF plot. You might consider this PMF plot for your presentation or in your publication. Now we move to the discontinuous functions. And as an example, we consider the density function fx equals to 0.5 times f1x plus 0.5 times f2x, where f1x is the density function of standard half-normal distribution defined on the negative real line including 0. So 0.5 times f1x is basically the standard normal density on that support, and f2 is the density of a standard exponential distribution defined on the positive real line. Note that this density function has a discontinuity at 0. First, we write the density function dmix with input x. If x is less than or equal to 0, we have the normal density, which is equal to 0.5 times the half normal density, and otherwise 0.5 times the standard exponential density. Then we consider the interval between -5 and +5. The most interesting point of this density function is at 0, and so we consider an interval around that. We create a fine grid grid.x over that interval and consider 10,000 grid points. In the last line, we evaluate the function dmix over that grid.x and store the outputs into the vector mix.density. Now we just need these two vectors grid.x and mix.density and forget about the rest. First, we just run the same code for the continuous case with some little changes. The inputs within aesthetics of the geom line are replaced by the two new vectors, and further we change the plot title from normal density to normal exponential density. Now press enter. Okay, you get your first mixture density curve. Note that the density function is right discontinuous at 0, but the curve we get looks continuous with a jump at 0. This needs to be fixed. To do that, append the value 0 into grid.x and append an NA into mix.density. If you have multiple breakpoints, just create a vector of those values and append that to grid.x. Also, you append the same number of NAs into mix.density. This can be alleviated by other special functions in ggplot2, but for the sake of simplicity, we choose this approach. Now, just run the same code we had previously. Okay, you get your second mixture density curve. Note that the curve looks discontinuous at 0, but it is difficult to see whether this is right continuous or left continuous. This needs to be fixed. We know that the curve is left continuous and right discontinuous at 0. To show this, usual approach uses a field point to show continuity, either left or right, and a white circle to show discontinuity. Now we fix this manually. So to show this left continuity, we add the field point at 0, the value of the mixture density at 0, using geom point within aesthetics x equals to 0, y equals to dmix at 0, and outside aesthetics size equals to 3. A larger size increases the size of the point, so choose a size accordingly. To show right discontinuity, choose a very small positive value. We choose 10 to the power minus 5 and add a blank circle at 10 to the power minus 5 and the value of the mixture density at 10 to the power minus 5. In the code, we add geom point within aesthetics x equals to 1e minus 5, y equals to dmix at 1e minus 5, and outside aesthetics size equals to 3, similar to the other case. Shape equals to 21. This creates a blank circle and fill the interior of that circle using the color white through the argument fill equals to white. Now press enter. Okay, you get your final mixture density curve. You might consider this curve for your presentation or in your publication. Today's discussion was about plotting a single curve. In case you need to draw multiple curves together, watch our video how to draw multiple functions together in R using ggplot2. If you found this video helpful, please like, comment, share and subscribe to my channel and press on the bell icon for more updates.